Hello बच्चों, good morning. So I welcome you all to your favorite channel Physics Made Easy by DCP. Myself Dayal Chand Pathak. So in class 10th we have started the chapter magnetic effect of current. What we were discussing? We were discussing about magnetic effect of current. Which chapter we are going to discuss? We were discussing about magnetic effect of current chapter. What is magnetic effect of current? In previous electricity chapter we have discussed that when current flow through a wire, that wire is heat up and we call it heating effect of current. We can say that current can produce heat. Then there is another property of current. Whenever current passes through a wire, through a conductor, then it produces around it magnetic effect. Means magnetic properties it produces. The current can produce magnetic property, like same property as magnet. Magnet properties, it attracts iron pieces towards its source of deflection in compass needle. These all properties are produced by current also. So now we will start. Who discovered this theory? किसने डिस्कवर की इस थ्योरी को? किसने देखा सबसे पहले इस थ्योरी को? दैट कि करंट कैन प्रोड्यूस मैग्नेटिक इफेक्ट. करंट मैग्नेट जैसा बन सकता है, मैग्नेट जैसा ही बना देता, अपने आप को मैग्नेट जैसा कर लेता है. हु डिस्कवर? द नेम ऑफ दैट साइंटिस्ट वाज हैंस क्रिश्चियन ऑरस्टेड. द नेम वाज Hans Christian Orested, and 1920 he gave this theory. Kabdi 1920 he gave this theory that current can produce magnetic effect. So what was the theory? According to Orested, current can produce magnetic effect. Yes, current produce magnetic effect. So what he says? He says that current can produce magnetic effect. Current क्या पैदा कर सकते हैं? मैग्नेट जैसा इफेक्ट पैदा कर सकते हैं. But question is that हैंस क्रिश्चियन को कैसे पता चला? कोई सपना आया उसको? No. He have done an experiment. इसने क्या किया था? एक एक्सपेरिमेंट किया था. क्या किया था उस एक्सपेरिमेंट में? इसने क्या किया? इसने एक वायर लिया, दैट इज कॉल्ड कंडक्टर, और इस कंडक्टर को इसने कनेक्ट किया किससे? थ्रू ए अमीटर, then that is connected through a cell or battery, and there was a key, and this circuit he made close. Now you all know that whenever a circuit, if one conductor is connected through a cell, there is a current in the circuit. Let the current in circuit is what I. Then what he done? क्या किया? Orested ने उसके बाद क्या किया? Now see what Orested have done. He taken a wire. He start flowing current through this wire. उसने क्या किया? वायर से करंट फ्लो करनी स्टार्ट की. So we all know, हमको पता है कि हमारे पास क्या होता है? compass needle. Everybody know, we have discussed about it in previous lecture. If you have not seen, you go through it. This compass needle will look like a rhombus, irregular rhombus. It is north, south, north, east, west. Direction is source. Yes or no? What he done? उसने क्या किया? उसने सर्किट में करंट फ्लो करी और इस सर्किट के नीचे क्या लेके आया? किसको लेके आया इसके नीचे? इस वायर के नीचे उसने क्या रखा? कॉम्पास नीडल. किसको रख दिया? कॉम्पास नीडल. Then what happened? The compass needle start deflecting. कॉम्पास नीडल ने क्या शो करा? डिफ्लेक्शन. मींस ये घूम गई. इट स्टार्ट रोटेटिंग. नीडल ने क्या कर दिया? रोटेशन. एंड कॉम्पास नीडल शोज द डिफ्लेक्शन ओनली व्हेन देयर इज मैग्नेटिक फील्ड. बट दिस वाज नॉट कंफर्म कि भाई मैग्नेटिक फील्ड ही हो रहा है, ये वायर ही कर रहा है. फॉर दैट उसने क्या किया? देन ही टेक इट अबव दिस वायर. कहां ले गया? इसके ऊपर ले गया. उसने इसको इसके ऊपर रखा. देन अगेन ही फाउंड दैट व्हाट ही फाउंड. He found that this compass needle start deflection in opposite direction. अभी यहाँ को कर रही थी, अब यहाँ को करने लगी. Then he changed this direction of current. उसने direction of current change की. So the deflection is also changed. तो उसने देखा कि when current direction is changed, then the deflection is also changed. When we change the position, the deflection is changed. That means the compass needle is shows the deflection only due to this current. So उसने एक statement सामने रख दिया कि current can produce magnetic effect. करंट क्या पैदा करते हैं? मैग्नेटिक इफेक्ट विद द हेल्प ऑफ कंपास नीडल एंड ए कंडक्टर इन बैटरी. इट शोज दिस एक्सपेरिमेंट एंड प्रूव दैट करंट कैन प्रोड्यूस मैग्नेटिक इफेक्ट. सो इसका थ्योरम था कि करंट क्या पैदा कर सकती है? मैग्नेटिक इफेक्ट. देन क्या किया गया? निकाला गया मैग्नेटिक फील्ड. निकाला गया किसका? ड्यू टू ए करंट carrying straight wire. फिर उसके बाद एक्सपेरिमेंट स्टार्ट हुए. सो फर्स्ट एक्सपेरिमेंट क्या स्टार्ट हुआ? इलेक्ट्रिक फील्ड ड्यू टू ए करंट कैरिंग वायर, ड्यू टू ए स्ट्रेट करंट कैरिंग वायर. क्या किया गया? इफ यू विल टेक, you can do this experiment. If you will take a first of all you have to take a cardboard for see this observation. What you have to do, you will take a cardboard. So this is a board. On this board, make a small hole at the center. Then, through this, you take a wire. So this wire is passing through this hole. This wire is passing through this hole. Then, what you can do? Then you connect it through a ammeter and then a cell. Or battery you can take. This is battery I am going to take, and a key, and close it. Make it close path. Now, what will happen? If current start flowing it, current, everybody know current will start from positive terminal to negative. Suppose the current start flowing, this circuit is I. Then according to Orested, it will start producing what? Magnetic field. So when current will start flowing through this this wire, when current start flowing, it will start to produce its magnetic field. So how you will check? If you will take iron filling here, आप क्या कर लीजिए? इस बोर्ड पर किसको फिलअप कर दीजिए? आयरन फिलिंग्स को. स्टॉप द करंट. फर्स्ट करंट को बंद कर लीजिए और यहाँ पर क्या डाल दीजिए? आयरन फिलिंग. देन व्हेन करंट स्टार्ट फ्लोइंग, जब करंट फ्लो होना शुरू होगा, यू विल सी दैट दीज आयरन फिलिंग स्टार्ट मूविंग लाइक दिस. They oriented themselves in circular paths. ये किस में oriented कर देते हैं? Themselves in circular path. And these circular paths are representing magnetic field lines. और यही circular paths किसको represent करते हैं? Magnetic field lines को represent करते हैं. किसको represent करते हैं? Magnetic field lines को. If the current is coming up to down, ऐसे आ रही है, तो these are oriented like this. ये इस तरह से oriented है. Their arrow will be like this. If you will change the direction, their orientation direction is also changed. In initial, when current is coming up to down, they are revolving like this. The circular path. If you will change up, down to up, they will start revolving like this. This and this. Get it or not? Let's see. देखते हैं. Next point. If you will change the directions, if you will change the direction, now suppose this is the cardboard now, and this is the cardboard. This is the hole. Now take a wire. This is the wire inside this cardboard. Connect this wire through a ammeter, and then a battery is connected through it, and a key is there. Close. Make it close. Stop the current. Stop the key, and take iron filling here. Now, if the positive is up, current will flow like this. In first we have discussed. If this upper is negative, मान लीजिए वाला क्या है? Negative terminal, and this one is positive. Now when you will start flowing the current will flow from there. Yes or no? Now when you will see, when current will start flowing through this wire, this iron filling start moving. Now they are start moving again in circular path. But now the motion is like this. See, earlier the motion was like this. Motion कैसा था? ऐसा. अब कैसा होगा? ऐसा. That means with direction change, they are changing their rotation also. So it proves that iron is going to attract towards this wire, that means this wire is produce magnetic field. So this was the experiment which proved that there is magnetic field around a current carrying wire. These lines which I am making a circular path, these are called magnetic field lines. These are magnetic field lines. These are not magnetic field directions. These are magnetic field lines. Force lines means these iron fillings are moving in this path. So iron fillings are moving. Iron जो लोहा है वो move करने लग गया. लोहा कब move करता है? When there is, why iron is attracting towards this plate, this rod? Because that means there is a what? Magnetic field. There is a magnetic field. Unit of magnetic field. Unit of magnetic field is Orested. At the beginning, when magnetic effect is explained by Orested, Hans Christian Orested, that time the unit was Orested. The unit of magnetic field is Orested. Why Orested? Because to give the honor to this scientist, Orested को सम्मान देने के लिए क्या रखा गया? मैग्नेटिक फील्ड की यूनिट को क्या कहा गया? Orested. But after that, in this field, magnetic effect of current में किसने ज्यादा काम किया? निकोलस टेस्ला. किसने काम किया? निकोलस टेस्ला ने. किसने काम किया? निकोलस टेस्ला ने इस फील्ड में आगे जाके बहुत ज्यादा काम किया. इसलिए आज जो मैग्नेटिक फील्ड की यूनिट है, टुडे मैग्नेटिक फील्ड यूनिट इज टेस्ला. तो मैग्नेटिक यूनिट की जो यूनिट है वो क्या है? टेस्ला है. किसके नाम पे है? निकोलस टेस्ला. लेकिन पहले क्या थी? ओरेस्टेड. बिगिनिंग किसने की? ओरेस्टेड ने की. ओरेस्टेड ने ही बिगिनिंग में ही बताया बाय एक्सपेरिमेंट दैट करंट कैरिंग वायर्स प्रोड्यूस मैग्नेटिक फील्ड. इसलिए उसे ऑनर्स देने के लिए क्या रख दिया गया? यूनिट ऑफ मैग्नेटिक फील्ड इज ओरेस्टेड. बट आफ्टर फर्दर इट Nicholas Tesla worked on this field. A lot of experiments, lot of theories were given by Nicholas Tesla. So due to that reason, today the unit of magnetic field is Tesla. This is very important question for the board exam. The unit of magnetic field is Tesla. In which system? In MKS. This is called matrix system. MKS means matrix system. जो एट द टाइम ऑफ ब्रिटिश राज के समय पर कौन से सिस्टम चलता था? मैट्रिक सिस्टम. उसकी यूनिट क्या है? टेस्ला. इफ यू फाइंड आउट इन सीजीएस, अगर आपको सीजीएस में देखना है, ग्राम सेंटीमीटर ग्राम सेकंड सिस्टम में इसकी यूनिट होती है गॉस, रिप्रेजेंटेड बाय जी. व्हाट इज द यूनिट ऑफ टेस्ला? गॉस. 1 टेस्ला 10 टू पावर 4 गॉस. एक टेस्ला में कितना होता है? 10 टू पावर 4 गॉस होते हैं. दिस थिंग यू हैव टू कीप इन माइंड. सो स्टार्टिंग क्या थी? स्टार्टिंग ओरेस्टेड ने की, उसका नाम पर इसकी यूनिट ओरेस्टेड हुई. फिर निकोलस टेस्ला ने काम किया, टेस्ला हो गया. फिर गॉस ने काम किया, गॉस हो गई. सीजीएस में गॉस कह सकते हैं, गैस में टेस्ला. नाउ so if someone will ask you that if iron fillings will be spread around a current carrying wire, then how they will move? They will start moving in circular path. Now the question is there, sir, how we will check what will be the direction of that magnetic field? Now see here. Rule for direction of magnetic field due to current. Now a task to check what are the rule for direction of what? Direction of magnetic field due to a current. What is that rule? That is called right hand thumb rule. Which rule? Right hand thumb rule. Means in this rule you will use only your right hand. How we will use and how we will find out the direction? Let's see. Very very important for your exam, board exam. Now what is right hand rule? What according to right hand rule? Right hand rule क्या कहता है? ये कहता है curl your right hand around current carrying conductor in such a way that your thumb represent direction of current, so your fingers will represent direction of magnetic field lines. What is the rule क्या कहता है? Rule कह रहा है, right hand rule कह रहा है, according to right hand rule, take your right hand, curl it, मोड़ लीजिए. Suppose this is the wire, yes, this I am going to take, this is the wire, this is a wire, and current is flowing through this wire, and this is the direction of current from bottom to top. The current is moving from down to up in this wire. नीचे से कहाँ जा रही current? ऊपर. So what is, according to right hand thumb rule, curl our right hand in such a way that thumb should be in the direction of current. Then the pointing, the top of the fingers represent the direction of magnetic field lines. तो thumb कहाँ को आ रहा है देखिए. Curl this, suppose this is the wire, current is flowing from bottom to top. So curl your right hand. Don't use the left hand, right hand. Curl the right hand around this wire. Thumb should be in the direction of current. So fingers will represent the direction of magnet. Let's see. दिखाता हूँ आपको. देखिए, यहाँ पर ड्रॉ कर लेते हैं. Suppose this is a wire. The current is flowing through this wire like this. This is the battery, minus, plus. Like this we are taking. Suppose the current flowing through this wire is how much? I. Current is flowing from bottom to up, means down to up. Down से ऊपर की ओर. Now we'll take our right hand, we will curl around it. We will curl our right hand around it. This is the wire. We will curl our right hand around it. Thumb should be in the direction of current. Now the fingers, trace the fingers. Fingers are revolving like this, I think. Yes or no? This is the direction. So this is the direction of magnetic field lines. This is not the direction of magnetic field. This is the direction of magnetic field lines. Now you see, you trace their motion. They are moving like this. At any point of this line, if we will draw a tangent, this is direction of magnetic field. This is the direction of magnetic field. So what is the direction of magnetic field? First of all, we will curl our right hand around it. Then we will trace the circular path. In that circular path, in their motion direction, we will draw the tangent. Suppose at this point you want to find out the direction, you draw a tangent. This is direction. At this point, tangent. Tangent will represent the direction of magnetic field. Now, let the wire is not like this. Wire as I. Now current is coming from up to down. Up to down. Now curl your right hand. This is wrong way. Thumb is moving up. Current is coming down. So you have to curl in such a way that your thumb should be in the direction of current. So now the thumb is coming down. Circles are revolving here. This. That means here the circles are revolving. How the circles are revolving? Circles are revolving like this. So these are the magnetic field lines. Easily you can draw the magnetic field lines by using right hand thumb rule. So at this point, now these are magnetic field lines. What are these? These are magnetic field line. Now here, what you have to do? If you will trace this path and draw the tangent, this is magnetic field direction. Direction of magnetic field. Getting or not? Very, very easy. So you will in board and competitive exam you will get the question. You have to apply this formula. So आपको क्या करना है? You have to curl your right hand in such a way around it. Your thumb should represent डायरेक्शन ऑफ करंट, बस ये ध्यान रखना कि थंब कहां आ जाए, डायरेक्शन ऑफ करंट। देखिए देन यू विल ट्रेस, देखिए देन यू विल ट्रेस द पाथ एंड ड्रॉ द टेंजेंट, यू विल गेट द डायरेक्शन ऑफ। लेट्स सी कुछ एप्लीकेशन देखते हैं कैसे हो सकता है। देखिए so this is, you can find out the direction of magnetic field by using which rule? A right hand thumb rule. Right hand thumb rule. Let's see. Question is there. Find direction of magnetic field. Let's see. Suppose this is a wire connected through a battery. This is plus and current is flowing in this wire. This is the wire. Now you are tasked to find out its magnetic field. Plus here, see here carefully. You see the current. Current is moving down to up. Very nice. Now put your left hand in your pocket. Don't use this. Use your right hand because the rule is a right hand rule. Which rule? A right hand rule only. Take your right hand near to this wire and curl your right hand around it. इसके चारों, see, I'm taking it out. This is the direction. Take your right hand, curl around in it such way that the thumb should be in direction of current. इस तरह से कर्ल कर लो कि thumb किस में आ जाए, direction of current. Current is moving up, thumb is coming up. ऊपर आ रहा thumb. So now trace the path. Fingers, see your fingers. Fingers are coming like this. देखिए, yeah. So now trace it. Fingers were coming like this. Yes or no? Now put the arrow. These are magnetic field lines. These are magnetic field. These are not direction. Now, where you want to find out? Suppose you want to find out the direction here. The arrow is moving like this. Draw a tangent. This is direction of magnetic field. Direction of magnetic field. Here if you want to find out, this arrow is going like this. Here at this point if you want to find tangent, this is magnetic field. Yes? So magnetic field direction will be represented by the arrow. So for this, but first of all you have to trace the circles. The circle will trace by right hand. Thumb rule. Getting? चलिए एक क्वेश्चन और ले लेते जल्दी से. चलिए सेम क्वेश्चन है, find the direction of magnetic field. Okay, now the wire is like this. This is the wire, this is the current flowing through this wire, and this is battery. This is the wire. By this wire, according to Orested, current is flowing through this wire. So this wire will produce what? Magnetic field. And now our task to find out magnetic field direction. For that, take the wire. This is the wire, and this current is flowing in this way. Left to right. Now take your right hand, curling in such a way that your thumb should be in the direction of current. See, coming. That means I will curl. These fingers are revolving like this. That means fingers कैसे revolve हो रहे हैं? पीछे चला जाएगा like this. See, this is current. Thumb should be in the direction of current. Fingers are coming like this. कहाँ से आ रहे हैं? ऊपर से नीचे. Up to down like this they are coming. See, yeah, this is outer face I am taking. इसको मैं बाहर वाला face, dot dot वाला मैंने outer face है, outer face. This dot dot one I am taking to outer face. See, this is current, this is the thumb, these fingers are coming like this now. Yes or no? So this is the, now you want to draw the direction. So this is the direction of magnetic field. Not attention on that. So you can check, you can find out the directions. Now just opposite question also you will get. This is very easy. I think you got it. Now next the question is like this. Find direction of current. Question is just opposite. Find direction of current. Suppose this is the wire, and for this wire this is the lines are given. मान लीजिए ये लाइन को काम करते हैं, पीछे वाला साइड हम इनर साइड है, इनर साइड को मैं डॉट डॉट कर दे रहा हूँ आपके लिए, उसके अंदर चला है. दिस इज आउटर फेस, दिस इज इनर फेस. इनर फेस समझ रहे हैं आप, अंदर का फेस ये है, डॉट डॉट वाला अंदर का फेस, और जो साफ दिख रहा है आपको बाहर का फेस. लाइक दिस, इट विल कम लाइक दिस ना, ऐसा आएगा. दिस इज आउटर फेस और एक अंदर आएगा यहाँ, दिस इज इनर फेस. ना देखिए जरा क्या होगी डायरेक्शन ऑफ करंट इन दिस वायर. लेट्स सी. करंट आर गोइंग अप टू डाउन लाइक दिस. देखिए इस पे देखिए, ऐसे जा रही ना करंट. थंब इज कमिंग राइट टू लेफ्ट, सो दिस इज द डायरेक्शन. देखिए अब मिलाइए तो देखिए, yes or no? Thumb right side, current up to down, up to down. Clear? So by this way you can find out direction of induced current by using whose law? Right hand thumb rule. Yes, so it was very easy. So what is the unit of magnetic field? Tesla and Gauss. Earlier what was that? Orested. Now next point is magnetic field due to straight current carrying wire. Now our task to find out the value of magnetic field. Let's see. Suppose this is a cardboard, and on this cardboard there is a hole, and through this hole a wire is passing. This is a wire, this is passing through this hole. You make a proper wire. Now we will connect this wire through a ammeter plus a minus. This is battery, minus plus minus plus, and a key, and then join to this. Now current will start to flow. Current will flow from positive to negative. This is the current in the wire. Now everybody know, if we will put the filling here, the fillings will start moving in circular path. Fillings will start moving on circular path on this table. This is the table. Yes or no? क्या है? Cardboard है. Now see on this cardboard, you will see that. Now use the rule. According to rule, put your finger. So the arrows, the circles will revolve like this. Yes or no? Now our task to find out magnetic field due to this wire at a distance r. Here at point P at a distance r, our task to find out magnetic field, value of magnetic field. This wire is going to produce magnetic field ना? Not here. चलिए ऐसा करते हैं, यहाँ ले लेते हैं. From this wire, our task to find out magnetic field at point P. At point P, distance r from this wire. We want to find out the magnetic field at point P. Now, how many factors? Magnetic field due to wire B. Magnetic field represented by capital B. Depend on following factors. Depend on following factors. Number first. किन factors पे depend करता है? Number first. Magnetic field directly depend on current. किस पे depend करता है directly? Current. तो B directly depend on I. Equation number 1. What is the meaning of it? It's a meaning when the current through this wire will increase. when the current through this wire is increased, magnetic field produced by this wire is also increased. More current, more magnetic field. High power, high magnetic field. Number second, it is inversely depend on distance of point from wire. B inversely depend on R. Everybody know when we will move away, जब इस वायर से हम दूर चले जाएंगे, दूर जाते रहेंगे तो फील्ड की वैल्यू क्या होती रहेगी? कम होती रहेगी, क्योंकि वो हमसे दूर होता जाएगा, उसकी पावर उतनी ही क्या हो जाएगी? कम. So that means if R will increase, B will decrease. So these two factors you have to keep in your mind. इससे आगे आपको नहीं पढ़ा रहे हैं, क्योंकि वो तो आप सब किस में पढ़ेंगे? 12th में. In higher studies, this is enough for you. From here you will get the question. If current will increase, field value will increase. When R will increase, field value will decrease. Yes, field value will be decrease. So R increase होगा तो field value decrease increase होगी. R decrease होगा तो field value increase होगी. Let which type of questions you will get. This is very important. Rest many formula आ जाते हैं, बहुत सारे फॉर्मूला हैं. मैं इसलिए नहीं पढ़ा रहा हूँ, आपके सिलेबस का नहीं है. चलिए. Now question. Suppose this is the question. Find ratio of magnetic field due to a wire of current 10 ampere at two positions 2 meter and 4 meter. Yes, this is the question. Question क्या है? Question is that find a ratio of magnetic field due to a wire. W is due to a wire of current 10 ampere. So there is a wire and the current through this wire R is 10 ampere. बैटरी से कनेक्ट होगा. छोड़ दीजिए क्या करना है. There are 2 points. 1 point at 2 meter, 1 point at 4 meter. This is suppose P and Q. Our task is find out the ratio of magnetic field at these 2 points. Now how we find out? See, we know a B directly depend on 1 upon R. B is depend on I also. I will be same for both the points. I तो same है दोनों points के लिए. Yes or no? Here the I is same for both the points. So no effect. So B inverse depend on R. So B1 directly depend on R1. This is equation number 1. B2 inverse depend upon R2. Equation number 2. What you will do? 1 by 2. So क्या आएगा? B1 upon B2 equal to proportionality equal to में 2 जाएगा. There will be constant cancel out. So there is no need. R1 1 upon R2. So it will come R2 upon R1. R2 is 4 by 2. It will come 2 ratio 1. 2 upon 1. It is coming 2 upon 1. So B1 ratio B2 2 ratio 1. This is the answer. Yes or no? Very easy question. Very easy question for competitive and for your board exam. This is the हलवा 1 question. कैसा क्वेश्चन है? हलवा है सर. हलवा तो है पर ये तो हलवा गर्म है, थोड़ा बहुत गर्म लगेगा. अभी आपको फ्रेश खा रहे हैं ना, इससे पहले तो पढ़ा नहीं है, तो इससे पहले खाया नहीं है ना, अभी ताजा खा रहे हैं तो आपको अकल नहीं है कैसे खाना है. खाने के अकल सीखे. चलिए एक और क्वेश्चन करते हैं. क्वेश्चन आगे मान लीजिए. क्वेश्चन लिख दिया. हाउ मैग्नेटिक फील्ड ड्यू टू a wire change when current increases. He's asking that when current is increases, how the value of magnetic field will change. Everybody knows. Answer? We know B directly depend on I. B is directly depend on I. If I will increase, so B also increase. I double कर दीजिए. If current is double, magnetic field also double. Current is half, magnetic field also half. So this type of questions you will get. So this was a small topic. Two topics we have discussed about Orested theory and how to find out the current due to a straight wire. So we have discussed few questions about it. So फिर मिलेंगे एक नई वीडियो के साथ. तब तक के लिए इसको करिए. So stay home, stay safe, and my request to you, please subscribe the channel, share it. If you love it, then share it. तब तक के लिए bye.